Good day, my viewers at home. Today's lecture, we shall be focusing on sequences and series. Now, at our elementary studies, we have actually known what a sequence is, a sequence of numbers, where we define a sequence of numbers as what? As a succession of numbers that are related by a common rule. When we talk about succession, if, for example, if you look at the number like this, 2, 4, 6, 8, 10, possibly. Now, you can see that this is just like a succession, because it's a succession of numbers in the sense that in this succession, our 4 succeeds 2. You cannot probably see that 6 succeeds 4, 8 succeeds what? 6, and so on. So what we are just having is a succession of what? Numbers. So every sequence is a succession of numbers. But not only a succession of numbers. In this succession of numbers, there is a common relationship between the successors. For example, you can see that, yes, 4 is a successor. 6 is a successor because 6 succeeds 4. In the same vein, 8 is what? A successor because it succeeds 6. So, but what is there is that between these successors, there is a common relationship. It might be that the relationship among them is the existence of a common difference or the existence of a common ratio. Nevertheless, but for this sequence we have here, you can see that the relationship between 6 and 4 is just like by comparing 6 and 4, let's say 6 minus 4 gives us 2. The same vein, 8 minus 6 gives us what? 2. So which means that there is a common difference between any two consecutive successors of this sequence. So the basic thing we should know is that a sequence is defined as a succession of what? Of numbers. A succession of numbers that are related by a common rule. A succession of numbers that are related by a common what? Rule. Now, at the elementary stage, a sequence may be in AP or maybe in what? In GP. There are two types of sequences. We have the one we call linear sequences, and the one we have another one they call what? The exponential sequences. So we have linear and exponential sequences. Linear and what? And let me call this one and this two. Linear and exponential sequences. So a sequence may be a linear sequence, or a sequence may be an exponential what? Sequence. But today in our study, we want to actually focus on what? On linear sequences. Then in the next lecture we're going to have, we shall then look at what we call the exponential sequences. Now, what is a linear sequence? What is a linear sequence? Now, another name for linear sequences is what? Is AP. Linear sequences is abbreviated as what? AP, where A means arithmetic and P here means progression. So we'll talk about arithmetic progression. So when you are given a linear sequence, it means that the sequence is in arithmetic what? Progression. So when do we say that a sequence of numbers is said to be in arithmetic progression? When can we say that a sequence of numbers is said to be in arithmetic progression? Or when can we say that a sequence of numbers is a linear what? Sequence? Very simple. A sequence of numbers is said to be in arithmetic progression when there is a common difference existing between any two consecutive terms of the sequence. A sequence of numbers is said to be in arithmetic progression if there is a common what? Difference existing between any two consecutive terms of the sequence. Now let me demonstrate this. If you look at this sequence, let's say the sequence I gave before, 2, 4, 6, 8, and 10. Look at the sequences. All these things are the terms. We call this the terms of the sequence. So this is the first term, this is the second term, this is the third term, the fourth term, and the what? And the fifth term. So this sequence is made up of 5 terms. But the issue now is that this sequence given to us, is it in arithmetic progression or is it in geometric what? Progression? In other words, is this sequence a linear sequence or not? How can I convince my examiner that this sequence is a linear sequence? Very simple. I repeat again from my definition that If this sequence is a linear sequence, then there must exist a common what? Difference between any two consecutive terms of the sequence. When we talk about consecutive terms, it means difference between the first term and second term. That is one step forward. One step forward. So if you have this guy had been the first term. The consecutive term to this first term is the second term. So the difference between the first term and the second term will be the same thing as the difference between the second term and the third term, and also the same thing with the difference between the third term and the fourth term, and so on. So if the difference is the same all throughout, then we cannot conclude that the sequence is in what? Is in arithmetic progression. But how do we get the common difference? How do we know the difference? Very simple. Please take note. The difference actually, how to get the difference in a linear sequence? Difference is equals to successor minus the predecessor. Successor minus the predecessor. All right? So now look at this. In this sequence here, now this is 2 is the first term, and 4 is the what? Second term. You can see that 4 succeeds 2, isn't it? That is 4 comes afterward 2. So 4 becomes the successor of 2, and 2 becomes the what? Predecessor. So of course, so therefore, if I want to find the difference between 4 and 6, it becomes 4 minus 6. So of course, our difference D will be equals to 4 minus 2. And what we get there? We get the value as what? As 2. In the same vein, 6 succeeds 2. And the difference between 6 and 4 is now what? Because 6 now becomes the what? Successor, and 4 becomes the what? Predecessor. So it becomes 6 minus 4, which gives us what? Gives us 2. The same thing continues. 8 succeeds 6. So difference here is equals to 8 minus 6, which simply gives us 2. So you can see that the differences between any two consecutive terms of the sequence is the same. Look at it, the same differences. So whenever there exists the same differences between any two consecutive terms of the sequence, we can then conclude that the sequence is a linear word sequence. The sequence is what? A linear word sequence. Now, this one is too elementary. We are not here to talk about linear sequences. Please remember, whenever a sequence is a linear sequence, that sequence is said to be in arithmetic progression. But we are not here to focus much on this aspect because this one is too elementary. Here, we want to, today, I intend to extend and to broaden your knowledge towards the application. What are the usefulness of linear sequences? If a sequence is in AP, or if a sequence is an arithmetic progression, what are the usefulness? What can we use these sequences? Of what use are these sequences to us in the world of mathematics and in real life? We're going to look at the applications of what? Of arithmetic progressions. So, we now move application of arithmetic progression. Applications of arithmetic progression. Application of APs. Now, one of the basic usefulness of sequences in arithmetic progression is that a sequence in arithmetic progression can be used. Arithmetic progression can be used to find or to calculate, to find the mean of two numbers. Arithmetic progression can be used to find the mean of two numbers. Now, when I say mean, the mean I'm talking about is the arithmetic mean. Please remember, we have different kinds of mean. We have arithmetic mean, we have geometric mean, and so on. There are many of them. All right, we have harmonic mean. But here, in particular, I am specifying about the arithmetic mean. So I am saying that a sequence in arithmetic progression has an application in the sense that it can be used to calculate the arithmetic mean of two numbers. Now, ordinarily, at the elementary stage, we know that if you are given two numbers like 2 and 4, we have numbers like 2 and 4, and you're asked to find the arithmetic mean of these two numbers. Remember, our arithmetic mean, let me say mean M, the mean will be equals to 2 plus 4 over what? 2. Because arithmetic mean is defined as what? As the sum of the terms all over the number of what? Terms. So therefore, our mean here will be equals to what? Will be equals to 6 over 2, which gives us what? 3. So what this means is that the arithmetic mean of what? Of 2 and 4 is what? Is 3. But now, one thing we notice, what we notice is that, notice something. If 3 is the mean of 2 and 4, watch your place. I have 2 and I have what? 4. If 3 is the mean of 2 and 4, when I insert this 3 in between 2 and 4, what happens? Watch. As when I come here and I put this 3, 3 is the mean of these two numbers. And I put 3 and I put this 3 in between 2 and what? And 4. You now observe that I have formed a sequence of numbers. I have formed what? A sequence of what? Numbers. So what it means is that if you are given two numbers and you can find the mean of those, the arithmetic mean of that two numbers, when you insert the mean in between the two numbers given to you, you form a sequence. The question I want to ask is that, is this sequence formed in arithmetic progression or in exponential what? Exponential progression? Is it a linear sequence or an exponential sequence? Or is a sequence in arithmetic progression or in geometric what? Progression? Very simple. When you look at this sequence here, we can see that 3 succeeds 2. And the difference between 3 and 2 is 3 minus 2, which is 1, isn't it? So our difference here is 1. In the same vein here, 4 succeeds 3. And the difference between 4 and 3 is what? It's still 1. So you can see that the difference is the same. So therefore, this sequence formed is in arithmetic what? Progression. Or this sequence formed is what? Is a linear what? Sequence. So this is one of the areas where linear sequences can be what? Can be applied. A linear sequence can be used. A linear what? Sequence can be used to find the what? To find the mean of two what? Numbers. To find the mean of two what? Numbers. Because we know that if the mean of two numbers is inserted in between the two numbers, we're going to form a sequence. We're going to form a linear what? Sequence. So now, how do we not define arithmetic mean in terms of linear sequences? How can the arithmetic mean of two numbers be defined in terms of linear sequences? Definition. Take note, please. All right. Now, the arithmetic mean of two numbers, let's say A and B, is defined as the number, let me use M for it, for arithmetic mean, is the number M such that when M is inserted in between A and B, so that when M is inserted in between A and B, the sequence, so that when M is inserted in between A and B, forms a sequence, and the sequence is like this: A, M, and B, which is in arithmetic what? Arithmetic progression. Which is in arithmetic what? Progression, or a linear sequence. A linear what? Sequence. So this definition we have given is the definition for what? Is the definition for what? For arithmetic mean. So the arithmetic mean of two numbers can be defined in relation to the arithmetic progression. The arithmetic mean of two numbers has a relationship with the linear what? Sequence. Now, from this definition, we say that what? That the arithmetic mean of two numbers, maybe A and B, like we chose our 2 and 4. The arithmetic mean of two numbers, A and B, is defined as the number m such that when this our m is inserted in between A and B, we are going to form a sequence of numbers like this: A, M, and what? And B, which is in arithmetic what? Progression. Which is in arithmetic progression. And I have already demonstrated this in the example I gave by choosing two numbers like 2 and 4. You can take as many examples as possible. If I choose, let me say if I take 2 and 6 as two numbers. If you are given 2 and what? And 6 as two numbers. Now, if I get the arithmetic mean of these two numbers and I insert it, okay, let me just say, if the arithmetic mean is, let's say, m, m is the arithmetic mean. When I find the value of m and I insert it in between 2 and what? And 6, I am going to form a sequence in what? In arithmetic what? Progression. That is, of course, for example, of course, I know that from the elementary state now, we know that the mean of 2 and 6 is equals to 2 plus 6 over 2. And that will simply give us 8 over 2, which is equals to what? 4. So what it then means is that, when I insert 4 in between 2 and 6, I am going to form a sequence in what? In AP. Okay, let me now replace this my m now. So my m now is 4, so I now put 4 here. So now, having inserted 4 in between 2 and 6, what do you observe? We have formed a sequence. We have formed what? A sequence. Now, but you observe that this sequence we have formed is actually in what? In arithmetic progression. Why? Because there is a common difference. Look at it now. Difference between 4 and 6 is what? Difference between 4 and 2 is what? Is 2. Difference between 6 and 4 is what? Is 2. So this sequence is in what? Is in AP. So whenever you insert the mean, the arithmetic mean of two numbers in between the numbers, you are meant to form what? You are trying to form what? A sequence in arithmetic what? Progression. This assertion or this notion cannot be used to calculate or cannot be used to insert the mean, or you can insert as many means as possible in between two numbers. So the exercises which I'll be solving now will dwell on what? You'll be given two numbers, and then you will now be required to insert the mean of these numbers in between the what? In between the two numbers given to you. So it's a very simple exercise that can be easily done. So we'll now take it and see how it goes. All right, we have a question here. This question says, this is example 1. The question says that we should insert one arithmetic what? Mean in between the number 2 and what? And 6. We want to insert one arithmetic mean in between 2 and what? And 6. Remember what I told you in the lecture in this lecture we are having? I have told you that whenever you are given two numbers, that when you insert the arithmetic mean of these two numbers in between the numbers, you are going to form a sequence in what? In arithmetic what? Progression. So we are going to use this ideology to determine this mean that can be inserted in between 2 and 6 to form a linear sequence. So solution. Now, I don't know the mean of 2 and 6. Let's assume that I don't yet know the mean of 2 and 6, such that when I insert that mean in between 2 and 6, I will now form a sequence in what? In arithmetic progression. So I'll just make an assumption for it. I can just say, okay, let the mean be equals to getting m. So if the mean is m, such that, let the mean be m, such that such that when m is inserted, in between, such that when m is inserted in between 2 and 6, we will now form a sequence in what? Such that when m is inserted in between 2 and 6, we will now form a sequence in what? Arithmetic what? Progression. Let me just make it clearer. Let the mean be m such that when I insert my m in between 2 and 6, that is such that 2, m, 6. 2, m, what? 6. Forms what? Forms an arithmetic what? Progression. Forms a sequence in AP. So I choose my arithmetic mean as what? I choose my arithmetic mean as m. So that when I insert this m in between 2 and 6, I will now form a sequence in what? In arithmetic progression. So that means this sequence I have here is in arithmetic progression. But this sequence contains 3 terms, where 2 is the first term, m is not the what? Second term, and 6 is not the what? Third term. So of course, this now implies, by implication, this implies that the first term a is equals to 2. The second term, let's say second term is written as t sub 2. T sub 2 is used to represent the second term of this sequence. Is now equals to what? M. And the third term, t sub 3, is equals to what? 6. But remember, we are claiming that this sequence is in what? Arithmetic progression. So if you are claiming that this sequence is in arithmetic progression, it simply means that you are telling us that what? There is a common difference existing between any 2 consecutive terms of this sequence. That is, a common difference exists. A common difference does what? Exists. So of course, therefore, it implies that, of course, I have my first term as what? As 2. The second term is the mean, which is unknown to us. We want to find the mean. It's unknown to us. But the third term is given as what? As 6. Now, here, third term t sub 3 is equals to 6. This now implies that, but remember that this sequence is in arithmetic progression. This sequence is in what? Arithmetic progression. For any sequence in arithmetic progression, we know from our previous knowledge that the third term is given by the formula a plus what? Plus 2 what? Plus 2d. The third term means a plus what? 2d. And what is the value here given to us? The value is given as what? As 6. Since the value is 6, then from here we have our a already. The first term is a is 2. So we have to substitute. We have to put the value of a as 2 back into this, into this relation. That now implies that 2 plus 2d is equals to what? 6. 2 plus 2d is equals to what? 6. So this now implies, okay, let me write this way. Let me write this place. So this now implies that what? This implies that 2 plus 2d is equals to 6, which then means that what? That 2d alone is equals to 6 minus 2, because I will take this guy to this side. So as he cross over, we now have it as minus, becomes minus here. So this equally means that 2d is equals to 4. And which equally means that what? The value of d will be equals to 4 over 2, which gives us what? 2. So we have gotten the value of the common difference. We have gotten the value of the common difference. And we have the fixed term. We have the fixed term. Now, finding the common difference and having the value of the fixed term is not actually what this question is demanding from us. The question is demanding that we should get the value of what? M, which is the arithmetic mean. Which is the what? Arithmetic what? Mean. So, but the arithmetic mean here is equals to what? The second term. The second term is the arithmetic mean. But remember that for a sequence in arithmetic progression, the terms of the sequence in arithmetic progression can be found when what happens? When the first term is known and the common difference is what? Given. So now I have my first term as a, and I have my common difference as what? As 2. So therefore, I can now go ahead to calculate the what? To calculate the value of the what? Of m. Now, okay, I have to rub some part of the board. So let me clean up these sides, these parts. All right. So now the second term is m. So now our m we are looking for is giving us the second term t sub 2. This now means that our m will be equal to the second term for a sequence in AP is normally giving us a plus d, which means that our m will be equal to our a is what? 2 plus our d is what? Our d is also 2. That simply means that the mean m is equal to what? 4. The mean is what? The mean is 4. So we have gotten the arithmetic mean as 4. So this thing is something that we would have done ordinarily because we can verify that this is true. That the mean of 2 and what? And 6 is what? Is 4. How? Look at this. If I have the number 2 and 6, the mean x bar is equal to what? Sum of terms, which is 2 plus 6 over 2, which will give us 8 over 2, which is equal to what? 4. So this is just an advanced way of finding mean faster. So 4 is the mean of 2 and what? And 6. But what we are claiming is that when you insert this arithmetic mean of 2 and 6 in between 2 and 6, you are going to form a sequence. A sequence in what? In arithmetic what? Progression. From this ideology, 2 becomes the first term. This our m becomes the second term. And 6 becomes the what? The third term. So from there, we'll now work it out by finding the common difference. And then using the common difference and the first term, we can now find the value of m, which is the second term of this sequence we have formed. So this is another way we can use to insert or to find the mean of two what? Numbers. By using the ideology that there is a relationship between the arithmetic mean and the arithmetic what? Progression. So we're going to be solving more problems in the next episode of our lecture. So thank you so much and keep on watching, keep on subscribing. God bless you all.